Okay, so number 1. We're in math. Okay, point of P is on the unit circle. All points are a squared plus b squared equals c squared, or x squared plus y squared equals 1. They all have Pythagorean theorem. It told me this one. They told me quadrant 1, so I wrote plus plus. And then I figured it out. It should have been the square root of 48 over 7. And positive, we had homework problems, kind of like that. B. I think everybody did pretty good on that one. D. Find the exact values of sine of 9 pi over 4. So that's going around the circle once and getting to 8 pi over 4, and then going one more to 9 pi over 4. You can go around and around the circle. That tells me 2 things, that you know that you can go around the circle, etc. If it's a pi over 4, you could automatically mark out A and C because it's a pi over 4. They have the same values, but you had to get the right signs. So it was D. E, find the exact value of the expression. Even on mine, I wrote, where is sine equal to this? Here's my half a circle, and I made the point and found the y value, and that happens at pi over 3. So E. This says, find the exact value of the expression. Conveniently, if I did this one right, which wasn't intended on my part, then I had that part, and then I found cosine of pi over 3. I just happened to notice they were the same problem, sort of. And then cosine of pi over 3. I already had the point up here. It was a half. So that was like a bonus. Multiple choice, there were 8 at 3 points each. The unit circle was 22 points, 1 for all of the things on there. Evaluate the expression by sketching a triangle. This one may have been a little bit difficult, but we did some triangles. We just didn't necessarily have it written out like this. Most of you did do a triangle. I didn't necessarily write it as a triangle, but I knew that sine over cosine was the 5 over 12, and then I was able to find the other value was 13 with Pythagorean theorem. Sorry, really itchy. And then once you have a triangle, you had to find the angle that had sine of 5. So opposite was 5 over 12, and then this was 13, and then apply cosine to that. So cosine is adjacent over hypotenuse, which is D. So setting up the triangle meant that you understood opposite over adjacent, and then you were looking for cosine of this angle, so 12 over 13. So this would have been the one which was, could you put it all together, a little bit harder than some of the other problems, maybe not exactly the same format, and occasionally in an honors class you might have a problem like that. They weren't all like that though, so that was just 3 points.
That's so hard. I got the 13 and I was just...
Okay, but is it better now? So Madeline says better.
Like you just saying that, like now that I know it's, I don't know, I did too. I got the 13. I got the 13.
And I went and drew a circle because I was thinking that in my mind, but I didn't even use it. Anyway, 6, graph the function. You need to know what they were. This one I said was sine, so I didn't consider it. This one is cosine. This one's sine, didn't consider it. This one starts down, which is not right. So I wrote negative cosine. This one's the right one, D. You didn't have to write notes on yours, but that's how I thought through which problem was which. I know that if it starts in the middle, it must be sine. If it starts at the bottom or the top, then it must be cosine, and I went from there. So D. 7, graph the function. So this is negative sine. So I wrote myself a picture of what negative sine looks like. And then I could cancel stuff. Like this one I canceled, this one I canceled. This one is cosine, canceled. This one is cosine. That's all I needed to know, actually. Then I went back and checked to see if my midline was at 4, and it is. There you go. But you could have canceled everything out based on whether it was negative sine or not. You could have thought through it. You could have made an XY chart. It might have taken you longer, but recognizing the function. And for some people, I said, if they ask me a question, I said, if you rewrite it in this order, that will help you see the negative. That will help you see the amplitude. They probably all have 3 amplitude. And then find the +4. So you can see I wrote a +4 here and here because they had it. These two did not. And then I didn't have to do an XY chart, but you could have if you needed to. Most of you got through that, figured it out, I would say. Cosecant has a period of 2 pi. These were the only 2 choices. If you recognize that cosecant and secant are used, so there wasn't a whole lot of specific graphing here, but definitely this is sine or cosine, and this is sine or cosine, so not those. This one had the wrong period, so even if you didn't try to draw it in, it had the wrong period. So A is the only good answer for 8. Convert each angle to radians. Meant you multiplied by pi over 80, which y'all did fine with. Some of you simplified a little bit awkwardly. You might have gotten a point off for just not being able to divide by 2 or dividing by something badly. Like 112 divided by 4 is not 66. That happened a bunch. 10. Okay, so 10 was worth 6 points. I actually don't think that I actually took off 6 points for any of these. I was thinking I wanted at least 4 points out of here and then 2 for the equation, but once you mess some stuff up here, it was hard for me to do the equation. So I kind of fudged the what I took off there to your benefit. And I really was looking for the midline to be a line. The vertical shift is the part where you say it just goes up 1, and I asked you to put +1. It says plus or minus. And then I really was looking for the actual period. So when you're thinking about period, you're thinking about how long it takes for you to start in any one place. It could be any place. It could be this place. But then to get to that same place over here, you have to go 8. You shouldn't start there because that's a dumb place to start. But if you start at 0 and find where you end with an up loop and a down loop, so you have the entire repeat. If this had been wallpaper, you'd need like, the top half of the monkey and the bottom half of the monkey to have a whole monkey. Then you would stop where you had a whole monkey. So it goes to 8. So 8 is really what I was looking for the period here. If you figured out the part that goes in the equation and put it there, then I might have, not taken off all the points. But if you totally just put 2 pi for the period, that's not the period for this graph. 2 pi is the period that sine or cosine the parent function has, and then this is a translation from that. So I was looking for 8 here. That's the actual period. The b value is what goes in the equation is pi over 4. They're different. The midline and the vertical shift, they go together. The vertical line and the vertical shift tells you what to put for the midline, but this is actually a line. It needs to be a line. Lines are lines. They need to have x equals or y equals. So equation-wise, y'all did here okay. Some of you a little bit iffy on the getting there. Although you could have written an infinity amount of different equations that would graph on the same line. We did that when we looked at all your equations for the sunrise, sunset. I really, really wanted you to start here so that I had to grade 1 equation and not 20. That's why it said start there, so that you were considering this the start point, and this graph would have been sine. This graph, I wanted you to graph at the point 0, -2, which meant it started a minimum value, which meant it was cosine, and negative cosine at that. I really was looking for this. If you gave me an equivalent one, I gave you credit for it because you're not technically wrong, but, throw me a bone every now and again so I don't have to make up 20 different equations. The amplitude for this one was also 2. That was not exciting. The phase shift was 0. That makes it really hard to figure out on the whatever, so I just made it easy. It was flipped. The midline is the middle, and some of you had trouble with that, and I get how cosine starts at the bottom, so you think it's been shifted, but the middle's still the middle. So if you draw the middle and then you can write an equation for that, that's the midline. And then it goes up 2 from there and down 2 from there. That's the amplitude. It wasn't actually shifted up or down. Cosine starts at a different value than the midline. So it's not shifted down 2. That's just the nature of cosine. In another stupid twist, I still made the period 8, so you have the same b value here. I guess I was lazy when I created this problem. So I tried to write notes on there. If you have questions about what I wrote, let me know what you got questions about. So do you get now what I was looking for? Period is different than the b value in the equation. Okay. Okay, so here, given the graph shown here, so there's a graph, and conveniently when I went to print these, I had to print on the front computer, so it came out in color, so it was so pretty and when it was printed in color. Anyway, given the graph, sine, draw its reciprocal function, which is cosecant. So I was looking for this. Some of you, weren't wrong when you said this. Again, you weren't wrong. I was looking for the other function's name specifically, but I don't think I counted off you writing 1 over sine x. It was worth just a point anyway. I was looking for asymptotes and the u. Some of you gave me these really tiny u's, which while I get, and I didn't take off for them, but this is not accurate. How come? Yeah, so it's trying to be the asymptote. Like, it should be out here, theoretically. So just case and note to self, as far as drawing accurate pictures, the asymptote is actually a boundary line. The function starts to become really, really close to the asymptote. And it starts at this point, and then it tries to be the asymptote. Those happen at 0. I got some really beautiful graphs, and then I got some totally random ones. So if you're having trouble understanding what the reciprocal graph does, go back. Those videos are posted, or come see me and let's graph some more. Like, put some more stuff in an XY chart. We didn't do a lot of XY charts here. We kind of said, this is what it looks like. Push the I believe button because it's easier to do. But you can let me know. 13. Why does cosecant? Ooh, hint for 12. That's what the function is. That was on purpose. Why does it have asymptotes, and what are they? So we're looking for k pi, or pi plus k pi, or 0. Some of you even wrote pi, 2 pi, 3 pi, ... and I'm pretty sure I gave you credit for that, even though I was looking for the k pi stuff. We're going to do more of that in this chapter, so get used to it. Because it's 1 over sine of x, where sine of x equals 0, cosecant has an asymptote. That's kind of what I was looking for. Most of you said something along those lines. If I could see it, I gave you credit for it. Number 14. If this had been the whole test, some of you would have failed, which that's just evaluating. That's just the basic math of the unit circle. So if you missed 5 or 6 out of 14, you need to go back and understand what it is that we're doing. Because you may have understood during the homework, or maybe you didn't and you just didn't ask me questions. I don't know. But this says, go to this place on the unit circle and tell me what this y value is. Here it is. Go to pi over 3, tell me the x value. That's this one. Go to 2 pi, which is start, and tell me about it. It's 0 over 1, which is 0. Arcsine, cosine inverse, and arctangent, those are the inverse functions, not reciprocal functions, inverse functions. The x and the y are swapped. So this says, instead of giving the where and finding out the x or y, you're given the x or y. This time you have to say, where is sine equal to 0? And that happens at 0. And if you told me 2 pi, you're wrong, because this graph doesn't go to 2 pi. It only goes from negative pi over 2 to pi over 2. 2 pi would be another whole iteration, and that would be multiple answers for this inverse function, not making it a function. Had to be 0. Where is cosine equal to 1/2? That's pi over 3. Where is tangent equal to -1? Again, this is that circle. This is that circle. So you had to know their range. Some of you had trouble with the next question we'll see in a minute about domain and range for these. Use the information given. You're starting here. You're going down. That's a negative value. Needed a negative here. This is the value smack dab in the middle. That makes it a pi over 4. So you count 1, 2, 3, 4, 5. Or you count, this is 4 over 4 pi. And so the next one is 5 over 4 pi. Doesn't matter to me how you count it or make sense out of it, as long as you can get there. It needed to be negative 5 pi over 4. 16. This is, were you following the inverse function section at all as far as the purpose of it? Because knowing why we do the things we do is important. So is the function sine of x a one-to-one function? So that's what sine of x looks like. It doesn't pass the horizontal line test. A huge number of students didn't know A. And one-to-one is not just that it's a function, it's that every x has a y and every y has one x. It goes backwards. So this was enough to say that answer. How would you have an inverse function? Limit the domain. We talked about that a lot because we limited the domain and we said in this case, everybody has to agree on the same thing. I really wanted you to show me this picture because this is what everybody uses across the entire world. If you limited a different one, I think I gave you credit for at least knowing that you had to limit it and doing it correctly. If you told me for C that it was this, that doesn't pass the horizontal line test either, right? Do you see it? Mm-hmm. So it couldn't be that. It had to be something that passes the vertical line test and the horizontal line test. And this is the one we agreed upon. This is the one that gives you the possible outcomes of specifically here to here, just this half. This goes with this, and this is the range, not the domain. So if you flip this, these are the possible answers, right? Not the domain. They're actually the possible, if you're asked about something in here, what you would give as an answer. So these are possible answers. That's why we draw this circle, because our answers can only come from the half of a circle. I don't think I took off 4 points for this. I was looking for you to write the domain limited here because this to have an inverse, it had to have a limited domain. I didn't count off if you told me infinity to infinity because you are just not that, you're just not there yet in the trig stuff. But if you told me infinity here, you're wrong. Madeline? Why do you have cosecant as the h of negative? Because I'm writing too quickly. So sine inverse. Yes. Here? Here. Yes. Here, okay. If you were just telling me sine, here, not okay. Right. Okay, 17, another application problem. I tried to give you hints. Most of you worked through this okay, probably depending on time, but I wanted you to hint, if you sketch important features, some of the wording will make more sense. Also, read it, because sometimes y'all don't. You're just like words. Nope. So here's what it looks like. It has a midline of 110, 110. Then it goes up 15 and down 15. This is 15 and this is 15. That's what amplitude means. And then what else? It says the maximum is called systolic. The minimum, biology people. Okay, diastolic. And we usually just, when we give them blood pressure, we say 125 over whatever. So they tell us right here, maximum and minimum. We know that from a graph. And so our graph has a maximum and a minimum. We can write it in the same form that they've given to us. There's enough words in there. You should have had some idea of what they're talking about. Or if you're lost, ask me a little bit and I can try to point you in the right direction. Most people got the number of heartbeats per minute, 75, but you might have been confused about how to write it here. So because this 150 pi t is written in there, if you take 2 pi and you divide by 150 pi, that's how we take the equation and change it into period. That's an equation we wrote a bunch when we first learned how to convert equation to stuff we know. And when you do that, you get 1 over 75. That means the period is 1 over 75, which means your little heartbeat, your blood's going 1 over 75. And then it does that per minute. It does it how many times? It must, if it does it once, in this, it does it 75 times when you get to be 1 minute. Does that make sense now?
Yeah, that makes more sense.
So I was looking for you to find period, even if you didn't know any wordy words. If you just said find the period from an equation, you should have done 2 pi over 150 pi without any words. And that's as per minute. Then how many? 175 a minute. Then that goes from that. Many of you may have guessed that. That's fine. But the blood pressure reading, that'd be where you have to read it because it says, they tell you maximum and then minimum. And so here's the maximum and minimum. And you have to apply it to this situation. What's the maximum in this situation? 110 plus 15 is 125. And then 110 minus 15, that's straight up from the equation. This is the minimum, maximum, minimum here. And then you compare that to this person, and these numbers are bigger. So it's higher. I wasn't looking for a whole, blood workup analysis of this person, but it's higher. Some of you subtracted wrong here. I can't help you with that. 110 minus 15 is 95, not 90. This was worth 5 points, but it didn't. 5 points shouldn't kill anybody. But should you be able to take an equation and pull some stuff out of it and make sense out of it? Yes, you should. And then you're going to circle, ta-da, there you go.